Hello and welcome to today's stream. On today's stream, I expect to continue advancing the governance simulation project. Um, on the previous stream, the main thing that has been achieved has been the ability to have a persistence strategy. That is, I was able to bring in persistence library, that is SQLite, and integrate that with the Swift directly without any wrappers or any ORM layer. So it's directly, I'm able to interact directly with SQLite C interface from Swift, which is really good, and that's good because there is no overhead that comes with working with the ORMs or working with the wrappers around SQLite. So having the ability to interact with it directly will help in having a more efficient and more optimized system. Then the other thing that I've been able to achieve so far is to model the structure of the simulation in terms of the kind of data layer that the simulation will be having. And this just involves defining the specific models and how those specific models operate. In terms of their validation logic, what kind of fields will exist within those models, and so on. So those two things are what I've been able to achieve this up to this point. So the next thing, there's two possible scenarios, like I mentioned in the previous stream. The first scenario is building up the persistence layer for the simulation. And the other option would be to start working on the logical part of the simulation, that is the individual micro models. These are tiny components, self-sustaining components or systems that exist within the simulation. I expect to have multiple quote-unquote self-sustaining models, and the business logic that connects those individual models. That is, in a regular system, you could look at that as the service layer of the system. And of course, having all of that again work within sort of a game loop, and having users have the ability to influence the state and behavior of the simulation from some user interface or some kind of input component. And this could be a CLI where they're able to plug in changes through commands, or a user interface where there's like a graphical user interface and they're able to click buttons, move spinners, use drop downs to determine the state of the simulation by kind of trying to influence it externally. So that also helps with the kind of presenting the state of the simulation to the end user through that user interface. At this point, I haven't decided whether that will be like a graphical user interface or I'll start off with the CLI. So that's a decision I still haven't made about the system. So at this point, I'll just look at it as some sort of user interaction layer. It could be a CLI, it could be a graphical user interface, it could be a web UI, something akin to HTML. It could be anything. After a while, I'll sort of settle on something, but only after building the actual internal mechanics of how the simulation works. So I given this some thought, and I decided that the best approach for this would be to start with the persistence layer, kind of complete all the persistence layer work, so that when I'm writing business logic, it's built on top of a persistence framework. So I'll try and do schema initialization with SQLite, try to have the queries that I need to do. If there's any indexing, get that indexing work done, so that there's an actual complete persistence layer that that the simulation can then be built on top of. So currently the simulation layer just has the link between SQLite, SQLite and Swift through the SQLite C interface. So for instance, this is, I think on the production side of the code, apart from the tests, this is the only persistence layer component that I've been able to put together, and this just obtains an SQLite object represented by this DB object, and of course it's an opaque pointer, and it just helps any part of the final code have like a centralized way of obtaining a database object. This helps especially when you're doing concurrency, or whether you want to ensure that all database objects are initialized from the same point, which means you can have some singleton-like behavior that ensures that you don't have multiple database objects floating around in memory. So having a centralized place kind of helps to isolate points of failure, such as having like a database object that has not been deinitialized after use. Yeah, so that is this function, and all it does is create a database object. There's a matching test for it, the DB initers. This should create a database object test. And what this does is just attempt to create an instance of GABSIM database, which is a struct representing our initialization function. I decided this should be an instance method, so that the objects the actual SQLite object is isolated to the instance of GABSIM database. And in my mind, I think that could help with ARC, automatic reference counting, that Swift uses to do what Java would consider garbage collection. So it just traces objects, and when they are out of scope, when they don't have like a parent object that initialize them still existing, or they are not being referred to by any child objects, then Swift automatically clears them from memory. So having it as an instance function, I think, will assist with that. Static functions are usually expected to float around in memory even when they're not being used. So making it tied to an instance, I think, might help with better memory management, so that we don't have these instances floating around. But of course, there is a method in the SQLite C interface. It's called, I think, SQLite 3 finalize. Finalize v3. I just go to the documentation. And that is responsible for clearing all objects that are created towards completing a database transaction. So just go to documentation. So for that object, for the database object that will be created from this method, I expect that the caller will call finalize when it's done with that object, and then the prepared statements, the database object, any strings representing the query will be cleared from memory after that database transaction has been completed. So once those are being cleared, Swift will probably notice that the opaque pointer has been deinitialized, and ARC will probably kick in and get rid of that instance of GABSIM database, which is the object that's responsible for creating new instances of SQLite objects. List of functions. I think this is where that should be. And I'm referring to finalize. Yeah, this one. So let's increase the font of this. So SQLite 3 finalize function is called to delete a prepare statement if the most recent evaluation of the statement encountered no errors, or if the statement has never been evaluated, then SQLite 3 finalize returns okay. Okay, this only clears the prepared statement. I think you have to call close for you to actually clear the database object. SQLite 3 close and close v2 routines are destructors for the SQLite 3 object. Calls to close and close v2 return okay if SQLite 3 object is successfully destroyed and all associated resources are deallocated. Yeah, so this is the method I was referring to. So I'm thinking if you don't call finalize for the prepare statement and eventually you call close, that prepare statement will still be cleared, whether or not you call finalize, as long as you call close. But calling finalize is just a much more healthier way to approach it, because that ensures that even if you don't get to a point where you are clearing the actual database object, the prepare statement and any queries associated with that prepare statement, which of course will end up being pointers because of how C handles strings, those will also end up being cleared. But anyway, enough of SQLite. So my strategy today is to just achieve one tiny goal, which is to do the database schema and CRUD functions for either all the three objects that we've defined so far, that is events, metrics, and policies, or at least one of them. At least one of the objects should have like an end-to-end create, read, update, delete set of functions, and maybe related indexes for any custom queries that I might anticipate to have in the final use for that repository. I'll be using repository pattern, so all the models that have been defined will have an equivalent repository object, and that repository object will contain the respective database queries for either fetching or updating or deleting, or basically the usual stuff that you normally do in SQLite, but isolated to that particular object. Yeah, so that is my main goal. So in the next few minutes, I'll just resume coding this up, and so let's see. Persons layer for list, pulled out persons. For listed models. So this is what I'll start with today. The simulations data layer. So this is more of a parent task. So I'll try to achieve this, and the other child task to this would be the ability to schema initialization. So once we have the schema initialization, then we build out the persistence layer. We can have persist initial data or state. So persist the initial state when simulation is started for the first time. And doing this might require us to do something extra. That is, we need to have a way of knowing that the simulation is being launched for the first time. And for that, we'll need to have a settings entity for storing user defaults and environment state, like whether onboarding is in this case it will probably be, it will still be onboarding, so whether onboarding is completed, onboarding completion status, and so on. So if this is done, I think in terms of persistence, the project will be at a fairly advanced stage, and I'll be more confident about the persistence layer. Right now, I'm somewhat comfortable with the persistence layer because we have that link between Swift and SQLite. But if we're able to perform actual queries, then I'll be more sure about things eventually working. So the goal right now should be to kind of get that done. So I'll try to do some of this the next few minutes. If I achieve a milestone, I'll be back to kind of explain what I've been able to do, and kind of get this moving bit by bit. So it seems I've made some progress with creating the draft for the schema initialization query. So this will be executed as a bulk query, and having this if not clause means we can execute that query multiple times without consequence. So it's I guess you could say independent. So it's safe to execute multiple times. And what it will do is if there is a schema that's already present, then the initialization logic will skip initializing that table. So if you're doing a create table for a table that already exists, then SQLite will be smart enough to not to like create duplicate tables or fail the initialization step. So I'm already down to an hour, which is what I was targeting for this stream. And I think I'll stop it there because now what we have is we have the query. We have this function that has not been completed. So I have this concurrent annotation because I'm expecting that anywhere this function is executed, it should be working in a background thread so that it doesn't affect anything on the main thread, depending on what the main thread will be executing. It might be executing the CLI interface, it might be executing a graphical user interface. I would not like that to be interrupted while we are doing schema initialization. Just in case the application wants to do something extra while doing schema initialization. So I'll leave that I'll leave the schema initialization to run in a background thread and not in any other thread. But essentially, I'm just isolating it from the main thread. So of course that for initialization, we need a SQLite object that will be represented by that opaque pointer. So this should point to an already initialized SQLite object that we can go ahead and use. And depending on how things go within the function, we expect a result object that either it has a success state and no value, that's why I'm using void, or if it fails, it should contain an error object that basically defines the error class or the type of error that was thrown by the function and any other information. So for example, within the test, if I notice that the database object has not been initialized, just checking it for nil, then I'll return this nil database error, which will have the message nil database object, check connection. So this is just a placeholder for test-driven development. I don't want to implement the actual schema initialization logic without a test to like signal back that initialization logic was actually completed. So talking of tests, so the test for that schema initialization is this schema init test. And what the test does is, first of all, it obtains a valid database object using one of the functions that was already defined earlier under GovSimDB. There's this get database object. So this should give us a valid database object. But the test is accounting for any failure state for when retrieving that database object. So I'm checking that when we call simdb get database object, we should get a result object, which is this db result, and that result object should have a success state, so it should not be a failure state. And we have this assertion that checks for that state. And just while explaining this, I've just noticed it would also be good to check that that db object is actually not a null pointer. So it's not, it should be pointing to a valid and properly initialized SQLite object. So SQLite object not initialized, nil pointer. So that extra assertion I think should help to just make sure that that database object is actually valid. So then if the database object is valid and we get a success state from the call, then we can move on to do schema initialization, which depends on that database object. And when we call init schema, we should get a result. So this will contain a result object, and I'm just checking for that result object to have a success state. We don't care about the value enclosed because the value enclosed is actually void. So we don't really need it. That's why I'm using that underscore value there. And now all I need to do is have an assertion for that schema result object, just to make sure that it's true. So it's only true if we get a success state when we call init schema. If we get a failure state, then this will remain false, and therefore the test will fail, which is what is happening right now because we haven't implemented that logic. So it compiles well, and it fails with this SQLite object not initialized, nil pointer. Actually, it shouldn't fail with this. Yeah, shouldn't fail with that. It shouldn't fail with that, and I think it's failing with that because this db object is probably deallocated once we leave this closure. The failure that I'm expecting is at the schema init level, not at the database initialization level. So perhaps what I can do is to move this logic into the closure, and Okay, I can move the logic into the closure so that I don't pass that pointer to another pointer. Did I lose the code? I was just copying. Okay. Whoa. Not lose this code. So this should live inside here so that we don't need this object. And maybe we don't need that step. And can have the rest of that there, and that means the database object will be that. I hope that's what the problem was. So the error was SQLite object not initialized, nil pointer. That. Okay, let me try and run this again. Yeah, okay, still fails with the SQLite object not initialized. What am I missing? Line 20. Yeah, it shouldn't fail here. Oh, wait, checking for the wrong state. So this, so the assertion should check that the database is not nil, not that it's nil, which might mean the other case was actually working. So if I execute with that, then yeah, so failed to init SQLite schema, expected success result. So that's where we expect failed to init schema. So this is the assertion that should fail, not that one. And perhaps I got too paranoid about the pointer thing, so they can bring this back to the way it was earlier. And I think I still have that on clipboard, yeah. And change this to not nil, so that the assertion passes if the object is not nil, not when the object is nil. So yeah, failed to init schema, expected success result. So that means we are getting a valid database object, and we are actually able to use that database object to attempt to initialize the schema. So at the end of all this, we should close that database object. So if db is not equal to nil, then we should call SQLite3 close and pass in the database object. Okay, this doesn't actually need to be a defer block because it's at the end of the test. Okay, let me just uncomplicate it. Yeah, so at the end of the test, we just need to kill that object and clear it from memory so that we don't have any problems with the test. So that's good. So in the next stream, I'll pick up on actually executing the schema initialization logic that is under schema. So I'll leave this hanging until the next stream, and in the next stream I'll write the code for using this set of queries to actually execute. And what we'll be doing is basically calling SQLite3 execute. I think it's exec. Yeah, and that will pass in the database object. We pass in some other values there. You can pass in, I think this is like a callback. We won't be using that. I think there's a simpler one. We might pass nil here, maybe. And so we'll just have a situation where we execute this and pass in the schema which will be the query in form of a string, and then we'll be able to execute that. Of course, there's a bit of complication because the Swift string and the C string are different, and I think from the other stream we learned that there's this utility function that we can call with string, and this will have the pointer to the string, and we can now now execute the query within that closure, and we'll be able to pass this pointer wherever it's needed. Just looking at SQLite 3 functions. Exec. Yeah, so this is the one we'll be using. Yeah, so we pass in a SQLite object. We pass in a SQL query, so that is the second argument. So that will be our pointer, and we are passing it. So just pass it in, and the other thing is a callback. We won't be passing in a callback function. First argument to callback, error message. Okay, so this is like a pointer that would capture the error message, but we can always call SQLite error message to get the error message, so we don't need to pass this. So I think we can pass nil for these two arguments, and hopefully get away with it. I was hoping there's like a variant that just accepts two arguments, which is the DB and the pointer, maybe exec. Okay. No, if SQLite doesn't have any problem with that passing in nil for the two arguments, then it should be okay. I think it's two, actually three. Yeah. Okay, so there's some complication there. Nil requires a contextual type, so we might need to have like a actual nil pointer, like cint, and cint for the callback. For the void, we might have an equivalent of a void type representation that matches the C version. I'll look into docs for that. And the error message, we could pass as an existing string and a pointer to that string, but I was hoping that I could pass in a nil for that value. Yeah, so that's what I'll be doing next. Right now, the time that I set up for this is done. So see you on the next one as we figure out how to work out this schema initialization step. I think it should be fun. Otherwise, if you joined the stream or you're watching this later, thanks for watching, and thanks for joining the stream. See you on the next one.